Hello everyone, I am a gang. Let's take a look at Slick. Actually, when we removed it for you just now, let me show you that we removed these elements that are not effectively useful. We actually said we need to adjust the size of this data. You can use a fixed capacity if you have determined its fixed length. If not, you can reserve some space in advance. This way, when you add data, you won't have to reallocate memory every time, which would inevitably lower performance. And repeatedly allocating memory will cause potential problems, such as memory fragmentation. So usually, when we delete elements, we don't directly release this memory. It will turn this block of memory area. 新图案 select element. This is equivalent to allocating it to this unused place. That is, in this memory region, it is still under the authority of our host. The amount of elements that we have already used, and the amount of elements allocated for use. That is the total amount of elements. The difference between them is the slack amount. That is, our total amount and existing amount. The difference between them is our slack amount. It's equivalent to A plus B equals C. A is what we have already used. B is what we haven't used yet. So C is the total that we possess, including both what we use and what we don't use. And generally, it's a number we construct. Initially, they are all 0, so slate is 0. It includes arrays. It is also 0 because we see that number, right? Its max is all equal to 0. Slack is equal to 0. Then we can use the max function to store its maximum number of elements. And then get the slack. It's actually the sum of the two of them. Look at this spot. First add an element. You'll notice that its capacity has increased to 4. Then the element 1 becomes 1. Then the undying element becomes 3. Then you'll keep adding more. So when it's 2, 3, and 4, there's actually no change. Then you will find that when it expands again, it increased by 16, right? Increased by 16. Then you now have a total of 5 elements. The empty one is 17. And you need to pay attention to our slack amount is definitely not a constant. It is a dynamic variable. It is a dynamic container. It will change gradually. Then we will simply demonstrate it. This Okay, let's simply demonstrate it. We call it slick away. Okay, we'll just paste this code here. We've actually demonstrated this before. It's still quite clear. Here, we are going to focus on demonstrating this part. We'll just output this inner. This way, we won't have to write too much. But maybe the room side would look better. We just need to call it max. This is a number. Here's the number converted into a separation, combination. Let's format this over here. The way to format it is by pressing counter and then selecting all the elements. Then let's look at counter plus K, counter plus F. When you press counter the second time, you don't have to release it. The text should be formatted like this. Then we might need to make it execute here again. We'll let it execute one last time. Let's see if it matches our expected effect. We will start it now. We disconnect it here. Then in this place, we should use xgsnap. The monster double-click should have a bend pape. We start it. Okay, after we launch, you will notice right? And then after we add the first element, you will notice this spot. It will turn into 3. No problem. Then we added 4 elements. Trigger, expansion. Then we can look at 17. These 4 is because we haven't refetched the latest value yet. it becomes 22, which proves that this entire workflow is okay. So at this point, we can think about how to optimize it. As for optimization, we can actually delete these old elements. Then first, if we want to close this host, we can use mpt. This way, it cleans up the original content. Then we can reinitialize it to have a capacity of 3, right? And then we add, this is a simple initialization operation. And this mp function will release everything inside, and then reinitialize its count. The difference with this reset function is that it won't free the memory. It only releases the original object. It doesn't free the memory. So our memory region is still managed by this group. It is managed this way. And also note that if the current slick one, it will have an expansion if it is not full. If your current one is relatively small, this will undergo an expansion. Actually, if you look here, this place is reset 0, but its max is 3. But when it resets to 10, it is equivalent to performing an expansion. Then regarding the share, it actually it's essentially when people talk about the minimum. So we demonstrated it by setting the amount of this slack to 0. Okay, let's continue by demonstrating these next 3. And then similarly, let's put them all together. We'll first demonstrate this one. Okay, we'll still use the same data. Let me take a look. We can take a look at this NPT, right? This here is Qingchen 3. Then go to this place and apply negative quality. Okay, no problem. Oh, let's just pull it out. Can paste it out. Then let's attach a few. Empty. Let's also create a reset. Okay, so let's create it. Then we'll move this over here. Generally, if we don't have a slick array, we are going to create a slick array, and it actually doesn't have any elements. We just add an element. Then add an add 10. And we add an 11. Okay, this side will reset to 0, right? Then we set it to 3. And finally, we add 123. Let's take another look at this effect. Let's add 1000, 2000, 2, 3, 4. Let's execute it now. Okay, after we open this up, let me try using it for a moment. Okay, let's set a breakpoint. Okay, we have an array here. Okay, after we declare it, it doesn't have anything inside. After we add 2 elements, it has something, and its max is 4. And it seems like we can't directly point out its slate here. Maybe it can only be accessed through a function. And then after we reset it to 0 again, all these things of it should be set to 0. Nothing at all. After we reset it to 3, its max becomes 3, and then it actually has no elements. Its slack element is 4. And then after forming 3, look, this spot still hasn't triggered the expansion, right? Because we finished filling this. We just filled in all of our elements. When we add another element, it triggers the expansion. See, right? It becomes 21, because originally it was 3. It expands, if it expands its capacity directly, expanding the capacity T2 T1. Right. Good. Let's just leave it at this. You scared me. Actually, this function we just covered, we've actually finished covering that. But in this part, you can see that if we execute it, it is actually like this. This 16 comes from here. Take a look. This place. Because this place does not have source code, so we cannot debug the ng. I wanted to tell you. His 16 is here. It's at this location. This spot of his goes to, let's set a breakpoint, which means we will fill this part and increase the capacity. this place. You can see here is a wait number. This is the first time. It returned a 4. It came in through this function. You can see it calling the battle. Let's look at its call stack. Here we define an array. When we add the first element, this place is equivalent to rescore. Its meaning is that we add it, right? We call it add. Then this place will check if this is valid, right? Check validity. As long as it's in these apps. The app's location, we add on deallocated memory regions and the undeallocated memory region if it's in this location after we determine this spot. It means that it needs to rescore, which is equivalent to reallocating. And the old count is 0. So after this rescore comes in, I think some judgments here. Finally, it returns an array max. This array max is its new capacity, and this capacity is determined by this function. This function uses a memory allocator, and the memory allocator calculates slack growth. It is done to it. Then it would be quite troublesome. It's relatively difficult to find. You can only look for it this way, and it's done through this. It's done through this. Let me take a look. It should go down here. This is the default one. And it actually calls this one. This is similar to allocating and calling the default allocation. Let's take a look at the default allocation container. It's just this. And there are two fields here. First, goal and const goal, these two values. So the 16 we mentioned is this. Regarding this, let me add a bit more information beforehand. If you want to know how this class allocates the area, this place has some calculation formulas. Everyone can take a more detailed look. We won't go into too much detail here. Right, because that previous one, 4 plus 16, is indeed a little ridiculous. Sorry, I miscalculated that. The 16 I was referring to is this. Right, okay. So, regarding our NPD, we've already looked at it. Empty is done. After we're done with NPD, let's take a look at the reset. That is, it won't free the memory. It just releases the original object. Let's take a look. We'll drop it. This piece of text is a bit dark. It shouldn't be discussed here. It was just mentioned in this section. So I'll take the opportunity to supplement it. If you are interested, everyone can try it out. Everyone, please take a look. Okay, for this part, we should still implement one. We can take a look at this reset. This part is the same as this. However, it won't change the memory allocation. Unless you set a new size that is larger than the current number. It will also call the acquire function. If necessary, this held object and at the same time clear the original memory to 0. That's essentially what it means. Clear this and take this. Set the quantity in the number to 0. Then we can take a look at it here. Let's add 3 numbers, or maybe just add 1, 2, 3. Okay, good. After we do it like this. Let's now see the result of its execution. Then we get to here, and then reset it. Let's set a breakpoint. Okay, after we come in, we modify and remove all these original breakpoints. This is what it has when its underlying inner layer is flying. Okay, we add 3 elements here. It has actually expanded to 4 now. Expanded to 4 for the first time, right? And then we continue. And over here, it is equivalent to resell 0. Let's look at this number again. It actually releases what's inside and executes this purchase function. If we increase the capacity to 10, you will find that it increases this capacity, right? So it won't, even though you currently pass a 0, but it won't free up this memory. Conversely, if the number you pass is large, it will also expand its capacity. That's the idea. Then Sherrick will demonstrate it to everyone. It takes all the currently unnecessary things and clears them all out in one go. That's what it means. Let's just run this quickly. Okay, I've actually cleared all the numeric elements from this area. And if we drop another sharek here, it should be totally empty. Let's run it again. Okay, and then here, just skip straight to the end. Okay. This is because we didn't save here. It seems like not saving caused it to run the last result. Okay, so because of this spot, we forcefully closed it, right? So this habit isn't very good. You force closed it. If you don't click save, it will lose the data. You have already written the difficulty data. After we enter now, we come to the spot. Okay, we can see that there is nothing here anymore. Let's directly share a look. Because we found it. We just cleared it out. So we cleared out these elements from the Slack. Okay, we'll stop our lesson here. For this class, I want to emphasize how did that 16 come about, right? Okay,